Okay, the next thing we're going to talk about, and we can't see it very well because there's so much stuff in the way, but it's this thing that looks like a muffler. Okay, the P2.5 air goes into that. The mixer muffler assembly consists of a muffler and bleed air ejector. The assembly combines regulated P3 air with either P2 air or cabin recirculation air and rotates this through the cabin. The ejector configuration ensures complete mixing of the air sources, thereby cooling the P3, which is hotter than the P2.5 primary flow, to the usable cabin heat source temperature. The cavity between the inner perforated tube and the outer shell is insulated with Nomex and fiberglass to reduce the noise of the air. Okay, the air diverter valve, or the mixing air valve, is this box right here, and it has two doors mechanically linked together, with both doors operated by a single mixing air control. In the ground position, P2.5 interstage compressor bleed air provides heat at power settings below 89% NG. And this is a great feature that the Caravan has, because a lot of times for your engine performance you want to know if you're lacking in engine performance. Usually one of the troubleshooting things is you have to find at what point in the NG bleed air valves are opening and closing. And usually on conventional PT6s you have to hook up a tube and put it into a Coke bottle that has some water in it and find out when it starts blowing bubbles and stuff. And that's a kind of a lengthy, tedious process. However, on the Caravan, since it has this mixer box, you open the air to it, and as soon as you get up to about 85%, you're able to determine that the bleed air on the P2.5 is closing at its proper setting of 85%. The P2 air is also used to augment the regulated P3 compressor outlet bleed air on the ground in cold temperatures. However, in flight, you never want to have this used, because it'll be sucking off P2.5 and 3 and just a little bit too much. Flight, you only want P3 operating. In the flight position, P2.5 interstage compressor air is dumped to the atmosphere. Cabin air is drawn into the muffler to mix with regulated P3 compressor outlet bleed valve. Okay, now we're going to become familiar with the control system inside the cockpit. Starting left to right, this is where you control your temperature. Okay, real simple. All it is ventilation to the diaphragm that we talked about, and it lets the diaphragm open and close. Right here's your bleed air control switch. Okay, this is for your P3. For your P2.5, you have your mixing control valve. It has some vents between the pilot seats and the door frame, and this controls that. It's not used very much because it's such a small cabin, but sometimes, and you need to check it on your maintenance checks. This one here is for your windshield defrost. Okay. Well, I was talking about earlier, you do not want to have P3 and your P2.5 on at the same time. You may get a compressor stall. and you don't want to have this open in flight. For flight, you just use this one. It says right on it, mixing air, ground, pull, flight, push. Okay, this may be a slight needed review. Air pressure in the full clockwise position. Okay, put this in the full clockwise position. Hot temperature control pressure is tapped inside the valve, increasing the temperature pressure up to 17 psi against the gate valve position. This opens the gate valve fully to increase the flow to the bleed air valve. In the counterclockwise position, okay, turn this all the way down. Cold temperature control pressure is vented through the temperature control gate, decreasing control air pressure against the valve piston. This allows the gate valve to move towards a closed position and reduces the flow of bleed air. Now during the ground operation that we talked about, below 89% NG, P2.5 interstage compressor discharge air is routed through the mixing valve and into the muffler. Mixing with the P3 compressor discharge air is ducted through the firewall shutoff valve in the ducting system. So you turn that off and pull this, okay, and that mixes 2.5 and 3. For flight operation, below 89% NG, cabin air is drawn through the mixing air valve muffler, mixed with P3 and directed into the distribution ducting. The P2.5 is dumped into the cowling area during flight operation above 90%. For flight operations below 89% NG, cabin air is drawn through the air mixing valve mixer muffler, mixed with P3 air, which is the hottest, and then directed to the distribution ducting. The P2.5, which is the cooler of the two, is dumped into the cowling area. During flight operation above 90% NG, the engine compressor bleed valve is completely closed to P2.5 air and no longer available for the mixing valve. Cabin air is drawn through the mixing valve and mixed with P2.5 air. Heating. What about cooling for the summer? Well, there is no air conditioner, but there is some ventilation systems. Okay, there's these ventilation registers on either side of the pilot and co-pilot's instrument panel. It does have this knob that can just pull out, okay, to open and close it, and there's a little tiny door on the side of the fuselage. Between the door, the cowling opens up to the airstream. We have these little vent doors that open up on both sides of the cowling to supply fresh air to the fresh air register. Also overhead, there's some overhead vents. Okay, this gets its air from ram air that comes in just above the upper wing strut and rams its way in through here. And normally it'd go to all the passengers as well, but since this is cargo, it only has these two overhead registers, and you control them by twisting this open and close, which controls a low valve inside here. Also, there's another, on the same system, there's another vent flapper valve that you open and close with this selector switch. There's only a very few scattered airplanes that have the electric forced ventilation fan, and to activate them, basically you just turn this all the way to open and a little bit past, and that will energize the ventilation fan, which is on each side of the cockpit on the wing root, just before the wing root area and the inside the wing. During some of the maintenance tests, we'll need to test the regulator setting, fitting right here. We're going to take it off. Okay, this separates. We're going to take it off, install this onto the ejector where currently the relief pressure valve is installed, and then once this is installed, we reinstall the holes and we run the engine up and read our settings. Okay, the ejector valve is located on the left top hand side of the firewall, just above the electrical J-box. And here's the exhaust to our ejector. If we follow this across, okay, this engine truss mount, right here is our relief valve for our ejector. This is where the air comes in, and then just behind here is where the line goes through the firewall and into the cockpit, and that's where it's going to create all the suction for the instruments. We're going to take this relief valve off and install this fitting that was on that hose. Once it's installed, we reconnect our hose and route it through the cowling latch and into the